Let us solve this differential equation. Now, from looking at it, we can solve it by direct integration. Let's try separating the variable and see. Let's see now. Suppose we factorize here. Let's take the y outside. So we have 1 over x squared dy by dx equals y times x to the fourth minus x squared. Okay, good. Now pause the video and finish it off for me. Okay, you finished? So let us continue. What do we do now? If we divide both sides by x to the fourth minus x squared, we're going to have 1 over x squared times 1 over x to the fourth minus x squared dy by dx is equal to y. Oh, guess what? I see. No, this is not what we would do. Instead of dividing by x to the fourth minus x squared, let's multiply by x squared dx. So we'll have 1 dy equals, when we multiply by dx, we have y x to the fourth minus x squared dx, and we multiply by x squared. So let's put x squared here. Alright, so there we have it now. And then we divide by y. So we have 1 over y dy is equal to x squared by x to the fourth minus x squared dx. Good. Alright, here we have x squared times x to the fourth minus x squared. We'll have to use the product rule, but we could just open the brackets and multiply out. Right, expand the brackets. So we have 1 over y dy equals, this would be x to the 6 minus x to the 4th dx. Alright. Now, we integrate both sides. So we have the integral of 1 over y dy is equal to the integral of x to the 6th minus x to the 4th dx. So the left hand side, we integrate it with respect to y, and the right hand side we integrate it with respect to x. So what happens here now? When you integrate 1 divided by y dy, we get ln y. Right? Now equals, integrate x to the 6 with respect to x, we have x to the 6 plus 1, which is 7, divided by the new power 7, minus x to the 4 plus 1, which is 5, divided by that new power 5, plus c, the constant of integration. Alright, what do we do now? Here, we have e raised to the power of both sides. So we have e to the ln y. On the left hand side, that would give us y clean. Alright? Because we have e to the power of ln of a function. We'll give you the function itself. On the right hand side, we have e to the x squared over 7 minus x to the 5 over 5 plus c. So now this really would be, well, if you separate it into e's, we have e to the x squared over 7. When you say e to the power minus a power, remember your rules of indices. This would be e to the 1 power divided by e to the power that you subtract. x to the 5 over 5. Alright, and then times e to the c. Right? You remember, it's like you're saying 2 to the power of 3, let's say 2 to the power of 4 minus 3 plus 1. It would be 4 minus 3 is 1. 1 plus 1 is 2, that will be 2 squared. But it's the same as 2 to the 4th over 2 to the 3 times 2 to the 1. Alright? So 3 of them, 2 to the 3, would be 2 to the 4 is 2 by 2 by 2 by 2. 4 of them, 2 to the 3 is 2 by 2 by 2 times 2 to the 1 is 2. So when you cancel down, you have to remember these things, you know. And then 2 times 2 give you 2 squared, right? You have to remember your rules of indices and your rules of logarithms as well. Alright, so back to this now. So what you have is y equals, let me see something, e to the x squared over 7 over e to the x to the 5 over 5 times e to the c. Alright, so this could be left like this, times e to the c. Another way you could do it is just leave this part with the e to the x squared over 7 minus x to the 5 over 5 and multiply by e to the c. But e to the c is yet another constant because e is a constant and c is a constant. So we could call it a times a. So we could bring the a in front. And say y equals a e to the x squared over 7 minus x to the 5 over 5. Right? Or you could say a times e to the x squared over 7 over e to the x to the 5 over 5. Right? All of them are the same. It's just that when you have the a, it looks neater. You could say y equals, and this just as it is. But having the a, e to the x squared over 7 minus x to the 5 over 5. It looks neater that way. Alright? Alright, so that's it for now.